corridor. Yes, well done. Revati, correct straight away.
So good, good, good. So Prasanna talking about data pre-processing. Okay, what do you do with data pre-processing, Prasanna? Good. Actually, everybody is really looks like you've got some good ideas about basics of AI, and then basics of Python programming, and you talked about some Python packages, Tanuja, and talked about box plot. Box plot represent what? How many points? And Makreshwari says introduction to AI, and Yoga Indra say thank you, sir. Very good. That is good. See, again, remember this word, appreciation, thanking others, having the gratitude. That those three are very, very important, right? I've been successful because of these three things. I've worked in US for quite some time. Americans are very good in terms of managing people and getting the work done from them, right? So if you look at it, hey, what's up? Oh, wonderful, kudos to you, appreciate you. You've done an excellent job. They start giving you all this, appreciation words. Thanks and appreciations are very important. Thanks, Yoga. Danuja says she has learned about mean, standard deviation mode, and somebody is talking about IoT, someone talking about IDE. Excellent, excellent. That's all? We want more. Give me more. That's all you discussed? There are some more you've studied. I hope you remember. I think Ranga said a couple of important packages. Can you recall some of the important packages which you have seen yesterday in Python? What was the navigator we have used? It is one type of a snake. Okay, good. NumPy, Keras, Panda. Okay, Anaconda. Very good. Looks like today Yoga and Revati are in form. That's good. Excellent. SciPy, Pandas. Yes, good. Excellent. Good. Mr. Ankur Rai, you are very quiet today. Again, today you are looks like a very handsome. Now only I'm seeing all the people faces. Yesterday I didn't get a chance to look at all people. Now, see, this is another opportunity when you're starting earlier. So you can see.
By the way, doctor, they were looking handsome yesterday as well. So.
Oh, really? Okay, good.
Not only today. Ankur looks like a Bollywood hero.
Yeah, true. Nice smile.
Nice. He's got a nice smile. We can see him. He's like us, happy-go-lucky guy.
Oh yeah, sure.
Good morning, Ankurji.
So much thanks, sir. Good morning to all of you. So it's a great opportunity for me that I got a chance to learn these all aspects of artificial intelligence and the machine and the Python yesterday. I'm from ECE branch, but I have so much interest in Python programming and the artificial intelligence, machine learning. I started learning by my own self, but when I found that when there is a FDP is running on this topic, I thought I should join this. But sir, due to because our classes are running, online classes are running, so it give me some difficulty. But I'm trying my best to be part of this FDP.
Excellent.
Really appreciate that. That's dedication, sir.
Yeah.
In spite of having the classes, all the professors are participating. We are really hats off to you all.
Yeah, because I know you have been doing so many other things also. Did we enrich your knowledge? Do you think that like we are giving you a kind of engineering approach, a structured methodology so that your learning can be improved? Do you feel that by looking through the agenda, through the ways we are covering, do you think that that's where today I'm going to talk about knowledge. Did we think that we transform the knowledge and you can use that knowledge to practice?
Yes, sir, surely, because what I have seen that from basics, few faculties have started. I mean, if we talk about the IoT and the Python programming, how to install the software, I mean, from the very basic. I mean, if anyone will join, they will understand. So,
excellent.
Sir, this FDP is enhancing knowledge.
Thank you. Thank you very much, Ankur. And thanks to all the participants. So we will start the session for today. I promised yesterday, myself and Ranga will be sharing. You can put your video off and mute yourself and all the people. So we're just going to get started the session today. I think there are 50 people. So far, I hope we will get keep it going. So I just wanted to share a positive point about what did I say I'm going to tell today? Do you remember what positive point I'm planning to tell today? Any guess?
Leadership.
Excellent. Who was that?
Sridevi.
Thank you, Sridevi. Yeah. So what was the positive point you have learned yesterday? 2 positive points.
Your thought is your karma.
Excellent. Anything from Mr. Ranganath's story about the elephant? Elephant was tied up with a rope. Use opportunity. Okay. Good, Tanuja. But the elephant did not use opportunity actually. The elephant was struck because the elephant's mind was struck. The elephant had Mr. Ranganath, what was the inference? Okay, don't fix. Excellent. Manivan was saying, don't fix your mind.
Yeah, don't fix your mind. Don't think you can't do this. Just because
Exactly.
somebody is constantly saying this or doing this to you, don't
Right.
believe. Believe in yourself and know your strengths. See, the elephant didn't understand his strength, so it just didn't get out.
Absolutely.
The moment if the elephant understood his strength, it would have broken the shackles. So we should also do that.
Excellent. Cool. So today the positive point is about honesty is the best policy, and especially which is important for leaders, right? Whether you are a HOD, whether you are a senior professor, associate professor, or whatever the the category you are in, doesn't matter. Okay. So that is the story is going to talk about that. So basically, there was a king. That king, I mean, he doesn't have any kids, so he wanted to appoint the next king because he became old, about 60 years. So since he doesn't have any kids, so he wanted to select the right king for the kingdom. So what he did was he consulted with all his ministers. So all the ministers gave an idea. Like in Vijay TV, GTV, and many TVs, we conduct so many rounds of competitions, right? So let us conduct some rounds of competitions to select the right king in our kingdom. Who will be the right king for our the future, right? So they started doing so many tests, so many competitions, right? So like martial art, and then horse riding and this and that, and then about Veda, about history and geography of the country, the everything. So almost like a couple of months of competitions happened. Finally, they filtered. They got 3, the potential king. I mean, candidate for king were selected, identified. So those 3 stood in front of king, and they all clapped them. And then now king was little confused. What should I do with that? Now we got 3 potential candidates. All 3 are very good. 3 of them are excellent in everything. But so then the senior minister gave a suggestion to king. He said some to him. Then king said that okay. 3 of you are equally good, but there will be one more a small test which we are going to give it to you, and you please do this. Now this country does not have enough resources, food resources and water resources. So because this is not a monsoon season, so we'll be giving you 3 bags. Each one will have a bag like a, in Tamil they call it as a chop pie, like one bag, like a bean bag or whatever, empty bag. So we are going to give you those 3 empty bags. You go and fill any food items you can fill. Okay. And I promise that I won't check what is there inside the bag. Okay. Go and come back after a week time. So like say today is Monday or Tuesday. So next Tuesday we are going to meet. So that was the assignment he has given to all the 3. So 3 of them went there. Okay. So the first person went there, he was initially very aggressive, right? He started, okay, I think let's start doing it. Let's start doing it. He started collecting some carrot, some, sweet potato, some banana, like that, He started grabbing some peanuts, whatever is available. He was just going around some few kilometers in that, radius, right? Kingdom area. So he started collecting it. Then 2 days he was very meticulous. He was wonderful. And after that, his mind started thinking, why I have to do this, man? Because anyway, king told that he is not going to check the bag. I will see what to do at the end of the day, right? So he started, because he was tired with all these 3 months of all the exercises and all the competitions, right? He started eating and sleeping, taking rest, right? And the final day, like before that final day, the Tuesday, the Monday, what he did was he started putting all the whatever things he collected, and then he started dumping some of the grass, that dead grass, and then some of the leaves and things like that, and try to fill even something which is not eatable also. He filled in and filled the bag like 70%. On top of that, he put those vegetables and things like that he has collected. So his bag was full. Okay. Then the second person, what he did was he started. First day itself, he became lazy. Let me do something, man. What to do? I'll maybe like the third day I will do. So 2 days he just spent some time sleeping and eating. Third day he was thinking, what should I do? Then he started collecting some, because he could not find any food items. He was going to the villages and places. He started finding some tomatoes and things like that available. I mean, they're all in the trash can. He started collecting all the things from the trash can because king says he's not going to check. Who will check? So he put all those things there. And then the last day, Monday, he paid some money. He went to some shops, the grocery shops, not vegetable shops. He started putting some vegetables and fruits on the top. So all contaminated food. And then on top of that, he put some nice, good food. He paid some money and got it tied up. The third person, right? What he was started doing meticulously every day, he collects something, some peanuts, some rice, some banana, something like that. Whatever he can get it, but his bag was not full. Every day he collects some about a kg of vegetables and things like that. So his bag was only 1/4 of the bag. And the last day was over. All the 3 people went there. And Tuesday they stood in front of the king. Then king says, good job. As I promised, I'm not going to check these bags. Okay. The guards, he called the guards, hey, put them in a jail. Okay. So 3 of them has to be in a separate prison, jail, and they should not be given any water. They should not be given any food. That's it. So now you know what would have happened, right? So the 3 of them are in a 3 separate jail, separate cell, and the first one survived for a few days because he got collected some food items. So with that he was able to eat, but rest of them all grass. So he cannot eat grass, and then you feel thirsty, and also he died on the 4th day. The second person died on the 2nd day itself because the good food and the bad food all got mixed up. So he got diarrhea, he got all this infections, right? And because the food was contaminated. The third person did, because he got all the good food items, so he was very healthy, survived. So the last day, after a week, only that person who collected good items survived. So king announced him as the next king, right? So this is the story on Positive Point today. So all the time, try to do your best. Try to be honest, right? Even though you get an opportunity for cheating something, don't try to do that. Try to always work continuously. You don't have to put always aggressive on one day. So in our session, all these 5 days, we will show the same pace how we did it yesterday. The same way it will go today. All 5 days. We will be like this. Myself and Mr. Ranga will be like this. We also want all the participants to be involved and be honest and then work. Whenever we say try, just try the code. With that intro and Positive Point, I'll hand over the session to Mr. Ranganath. Ranganath, you load your presentation. I'll just show the agenda for today is
okay.
Yeah, just the agenda, what is that we are going to cover today that myself and Mr. Ranganath have already discussed. The agenda is Mr. Ranganath will be giving a primer on machine learning. Okay, I didn't share my screen. Just 1 second, Mr. Ranga. I'll just share my screen quickly. Okay, so we will be covering the primer on machine learning. This is as per the agenda, the 5 days agenda. Then there is a types of knowledge. Whenever there is a possibility, you improve and correct your mistake, right? Then and there, correct the mistake. So types of knowledge and types of agents, AI agents, that will be covered. So Ranga will be covering the morning session, and then I will pitch in on the types of knowledge. Then we'll talk about types of logic, and there is a famous game called Wumpus game. So Wumpus World. So we will be exploring you with that, and then we'll talk about reasoning system. And today focus will be more on the fuzzy logic. That is very important for AI. So we'll be covering that fuzzy logic and agents. And then we will again in the afternoon, we will show some codes on the machine learning. Then in the end of the session, like evening, like last time, so I'll be discussing more about some of the other statistics like similarity metrics, how to find out distance between these, and teach you about Manhattan distance, Euclidean distance. There are few statistical related codes and things like that concept will explain. So with that, Ranga, I'm done. I'm stop sharing. You can take your presentation. Thank you. Have a good day, everybody. I'll also along with you.
Good morning, everybody. I hope all of you are doing fine and ready for another interesting and enticing session. So thank you for all the people, all the participants, all the professors and the doctors who have joined back again today on time. Really appreciate that. Thus, this tells us that you have faith in us. Okay, is my PPT visible and is my voice nice, loud and clear? Please confirm.
Yes, sir. Yes.
Yes, Mr.
Okay. Also, Sudha Madam, I have sent you an email. Please share those files with the participants. They can use that CSV file for the machine learning hands-on. It's not urgent now. You can do it like I just said.
Okay.
So today we're going to be. I had not put the video on just for the bandwidth sake, so that everybody is able to connect and hear. So we're going to be talking about the machine learning part of artificial intelligence. So what is artificial intelligence is what we saw a little bit yesterday. It comprises of machine, as I said, it comprises of data science, data mining. Within data mining, we have machine learning. Within machine learning, we have deep learning. Within deep learning, we have reinforcement learning. So some of the artificial intelligence based products are these logic rule-based systems, expert systems. We're going to be teaching you today about these rule-based systems. This is fuzzy logic, temporal logic. These are two very interesting systems, and we are also going to be talking about propositional logic, first order logic, and those kind of stuff theoretically. And we'll also be giving you hands-on on fuzzy, quite an interesting one. And you see fuzzy being used all around you. Fuzzy logic is there in your air conditioners. Fuzzy logic is there in your washing machines. All the automatic washing machines use fuzzy logic. Once you see the presentation, you will be able to easily connect. So doctor did cover something about the statistics and probability. He's going to cover more today. If time permits, I'll speak some in the evening session. Doctor, please remind me as well. I want to give some inputs to the participants on information theory 101. It's quite an interesting concept as well. And it is very, very much related to probability, conditional probability. Then we have machine learning, which is a part of the artificial intelligence. So we'll be going through machine learning today, and I'll be showing you regression, simple linear regression. We'll have hands-on. I'll do one. We'll all do a couple of programs together, so you get a hang of it. Doctor will cover decision trees, nearest neighbors classification tomorrow. We will be covering neural networks, deep learning, and a little bit on text audio processing. So basically, it's used for prediction, fraud detection, automation, augmentation. So basically, that is what AI is pretty much used for. Just to give you a bearing on where AI started and where we are. AI started somewhere around 1980s, and the first generation was a rule-based system. We're going to see this as well. Still, it uses it. Still, AI uses the rule-based system because it needs to decide if this is this, what do I do? If then what? So this was purely rule-based. Now the rules can also be done on the fly. Then came the second generation. That's where they applied more of the statistics based on the statistics and search model. So this is why we were referring to having a good grab and hands-on on statistics. Linear algebra is going to help you big time in achieving greater research results and coming up with different products with regards to AI. Then we had audio assistant. Then this AI Japanese chess. We're going to be talking about of those kind of fuzzy logics as well as the greedy search algorithms that it uses, A-star, min-max algorithms we spoke about yesterday. And today, the third generation, as you can very clearly see, we are trying to brain model. We're trying to ape how a human can think. How does the human brain work? So that's what led the research into deep learning. So we'll be touching upon that as well. So this is a very good yes.
Ranga?
Yes, madam.
Ranganathan, your PPT is not coming. Deepika, I think there is one participant by name Deepika, and her presentation page is there. Please, Deepika, you turn off your presentation mode.
Yeah. There are multiple things. Deepika Sharma, please stop your, stop your sharing.
Oh, sorry. Yeah, I can see. Okay. Thanks, madam.
Yes, left from the meeting, but I think you have to close. Madam, you just close that.
Deepika Sharma is presenting. Resume presenting. I'll just do this. This will take over. Deepika
Yeah, now you
share.
share.
I'll take over.
Yeah, exactly.
Maybe there is an option we can figure out too.
You use the pin, Ranga, that in your presentation. You pin. Yeah. There you go. Maximize it. Go to minimize your whole window, and then
How is it?
Yes, good. Now you can put a slideshow.
Yeah.
No problem, Deepika.
Okay. You can see it now?
Yes.
Yes.
Okay.
Yes.
Thank you. Yeah, good that you have to tell me because I'm talking, looking at my presentation, so I wouldn't know what's going on. Thanks, madam. So as I was saying, artificial intelligence is the whole encompassing part within which we have machine learning, which is a subset of AI that involves programming system, and then the deep learning is a subset of machine learning, from where you will learn from hidden patterns. We will see the differences. Okay, basically machine learning is kind of having to code rule-based instructions. Here it will build its own rules and try to learn by itself. So this is another representation. So artificial intelligence is any technique that enables to mimic the human mind. Machine learning is more of an abstruse statistical technique. And here comes deep learning, which is that can permit the software to train itself. So I'm going to keep showing my deep learning model a whole bunch of pictures. If I show the model to 1 lakh dogs, all different breeds of dogs, that's enough. That's it. It will train itself. The next time you show a picture of dog, it'll say dog. So we will see all that. It's quite interesting. So this machine learning is divided into unsupervised learning, supervised learning, and reinforcement learning. Supervised learning is basically classification and regression. We'll be looking at that today. Pretty much used in identity fraud detection, image classification, customer retention, diagnostics. You want to classify something, okay? You want to forecast something. When it comes to regression, you want to forecast. Will this work? What is my weather forecast? What is my market forecast? Will the employee retreat? How many students will join? See, for example, people are using machine learning everywhere. I'm just giving you an example on right off the fly, on the top of my head. As an organization, as the colleges, some of them are using, all the colleges I think should implement, so they can have the data from all the previous years, and they can build a machine learning model which will give them a fantastic forecast prediction on the admissions. So how many admissions you are expecting for EC, how many expecting for, from which part of the town people come from, which part of India people come from, what is the majority. So all that can be very nicely predicted. So it's a very good tool, and quite a few colleges are using it. And unsupervised learning comes under the following things, which are dimensionality reduction and clustering. As we were talking yesterday, if all goes well and AICTE permits, we can conduct machine learning, exclusive deep learning sessions, because you guys have gone through the basics. So these are some fantastic areas where these recommender systems is what Amazon uses. Netflix, I'm sure all of you with the COVID, pretty much everybody has a Netflix connection, right? How many of you know what Netflix is? Anybody responding, doctor? Netflix, Amazon Prime.
Not yet. Yeah. Yes. Video on demand.
Yeah, video on demand. So when have you guys noticed when you go into those Netflix or Amazon Prime, there's a whole bunch of recommendations. I think you should watch this movie. That's all done through machine learning. It's all machine intelligence. It's seeing what you like, and it's exactly how when you buy one product in Amazon, there's another product that's being recommended to you. When you log in immediately, they'll show you like, those are all very interesting stuff. And there is also a concept called as a priori algorithm. Those are also very, very interesting market basket analysis. So those are some very interesting analysis where people use it in a day-to-day affair. So what is the difference between these three? And also, reinforcement learning. We're going to be talking about reinforcement learning as well. Robo navigation, learning tasks, skills, game AI. Supervised learning is labeled data. Data is already labeled. It gives a direct feedback. You will predict the outcome of the future. There is already, the result is there. The data has already been labeled. Based on the previous data, it says, okay, whether let's say, take an example, if the person has temperature, he's coughing, he's been down with fever for 3 days, the actual result says the person has got COVID. So your supervised learning will take all that labeled data, and if it predicts the outcome that he will have based on what it learned, then we will do a prediction minus actual, and we calculate the error. We'll try to reduce those errors. Unsupervised learning, there are no labels. Clustering, we're going to see it tomorrow. Amazing. Doctor is very good at that. Tomorrow he's going to show you how you will be able to cluster something. Say, for example, good example on unsupervised learning clustering is, let's say there are so many colleges out there. We'll talk what we know. There are so many colleges out there, right? If you look at overseas, especially in US, UK, there's a lot of ranking, and they rank it on a lot of different stuff. But a similar kind of stuff is not, maybe it's available, but it's not available to a great extent to measure all the different universities within India. So you can use clustering to cluster the universities as Ivy League universities, top tier universities, top second, top 3, top 5, So you can cluster those universities based on certain labels. So I give you data, it's got hidden structure. So you will look at it and you'll be able to cluster it and produce it. So people do use that big time. Where do they use it? On real-time areas, like it's used in credit cards. They will cluster the customers. What type of customers are these? So what type of emails do I send to these customers is done today. Insurance, they will look at who the types of insurance, what is the different clusters of insurance people I have. What products should I recommend? Companies are using it big time. You'll be surprised. Reinforcement learning is basically a decision process and a reward system. So you make a decision. If it is good, you get a good reward. If you don't do well, you get minus points. So you learn from a series of actions. So it's again the same one because it's colorful. So I have this colors. I like colors. So how different is traditional programming from machine learning? So we'll be looking at some of the basics. So do not discount these theory slides. This is your base for your entire artificial intelligence. Does not mean, even though the topic on the header might say machine learning, whatever I am covering in this session, this is a very, very important session, is the basis of all your machine learning and deep learning. Doesn't matter. This is how it works. The algorithms differ, but this is the base. Okay. So the traditional programming, you get an input, you give a logic, you get an output. But when it comes to the machine learning model logic from data, you give training input and you give also the expected output. Hey, this is what I'm expecting. So what are you giving? You train your machine learning. Once it learns from a whole bunch of training stuff, then it will be able to predict. So it is like I am training to all of you to teach AI. Let's say I'm going to train you to teach machine learning, simple linear regression. I give you one problem and you solve it here, and you go back and you try to teach, you might not be good at it. Let's say you practiced 10 simple linear regression problems. You will be 20% good. What if you did 50, 100? Let's say you practice 1,000 simple linear regression problems. How would your output be? It is pretty much close to how I taught you, right? So you'll be able to, the more you train, the better. Okay, there is also another thing of overtraining. We'll also cover that later. But the question is more, the knowledge you have, the better you will be able to deliver. So here is where all these knowledge systems come into play. So this logic goes in here, then the ML makes an inference and gives an output. Okay, so far, are you guys able to follow? Is it kind of interesting and trying to make sense? Responses, please. Or is it boring?
I'm just checking.
Are we making sense? Are we trying to put building blocks together?
Yeah, they are saying interesting. They are just following. Go ahead.
Okay, perfect. So when it comes to analytics, there are 4 types of analytics. One is descriptive analytics, diagnostic analytics. Then we have predictive and prescriptive. It's pretty clear from the picture. Anything with regards to analysis on the past is descriptive and diagnostic. Anything to the future is predictive and prescriptive. Okay, the complexity increases if you're going towards the future. The value also is more because you're looking at the future. Past is okay, so you did so many mistakes, or you did that, you did this, but what's for future? So people are looking for future. So predictive and prescriptive are pretty interesting. The name speaks it all. Computer science, common sense. Go back to my dictionary. Computer science is common sense. Descriptive analysis is nothing but, analytics is nothing but, it just analyzes the incoming data in real time and the historical data for insights on how to approach the future. So if it, let's say you're getting an IoT sensor data that's coming in that we saw yesterday, it can check on the previous history. So let's say an IoT sensor is sending a noise from a machine. So it can immediately go back and check the history and say, hey, wait a minute, this similar kind of noise came from this sensor 6 months back and it led to a breakdown. So this is a problem. So immediately it says that, and it gives a description on what is going to happen, right? So these are all the problems that can happen, is the descriptive analysis. It's business intelligence and data mining. Predictive analytics is prediction. Always, what is prediction? Prediction is about future. So you forecast. So that is the next step in the data reduction. You will provide answers to the questions which cannot be answered by the business intelligence tool. So this basically tells you, predictive analytics, what will happen next if a certain condition, why this actually happened, or you can identify correlated data. So I said this descriptive IoT came back and told me this noise created a problem 6 months back. The predictive analytics will tell you what will happen next if you don't address this condition. If you don't pay attention, the machine is going to break down. You will immediately work on it. So that's where the predictive analytics come into play. Prescriptive analysis. Who gives you a prescription, ladies and gentlemen? Where do you hear the word prescription? Who gives you prescription? I can hear some responses, but don't see. What's the response, doctor?
They have given doctors.
Doctors, that's it. So once you become a data science, data analyst, or a data science specialist, or an AI specialist, you're also a doctor. You don't have to write NEET, like what the kids did on Sunday. No more NEET. We are also doctors. Prescriptive analytics is an advanced analytics concept based on the problems. We'll be producing what kind of a solution is better. Say, for example, you can, if you are applying for a credit card, right? We are using prescriptive analysis. What it is, when you apply for a credit card, I'm sure all of us now know it was very famous in the US. Now it is caught up here as well. There is something called as credit score. So you have to have a specific credit score, credit points to be given a loan. So it will check the credit score, and the financial institution will say, hey, I know what, this guy has been good with credit scores. Like when your credit score increases is when you keep buying, taking a lot of loan, and you repay them. If you don't repay them and you have bad debts, like Vijay Mallya, right? We are not Vijay Mallya, unfortunately, right? And we don't want to run. Then your credit score is bad. The financial institutions might decide not to give. So this is one of the areas where it's used. Say, for example, healthcare systems also use prescriptive analysis. Okay, this is a problem. You take this, otherwise you might end in a trouble. So putting this all in a perspective, analytic value escalator, descriptive analysis tells you what happened. Diagnostic analysis tells you why it happened. Predictive analysis says what will happen. Okay, why it happened, what will happen. Prescriptive analytics say how can we make it happen. Okay. So
Ranga,
yes.
Mr. Ranga, I asked one question related to your covering in terms of credit card. Okay, I'm looking for some answers from the participants. You can put the question also. So basically, if a company has to offer credit card to person A, okay, you are getting the call, and what are the things they collect and why they have to offer the credit card. So you can put the question so that we will hear some answers from the chat window.
Go ahead. You have put the win anyway. Why Citibank has to offer credit card?
Yeah, please answer. Shoot the answer. So that is related to what Mr. Ranga was describing about the analytics and what type of analytics. Yeah. Oh, good. They're giving. Yes. Continue, Mr. Ranga.
Yeah, welcome. Can I continue? Okay.
Yeah, minimize and then go to your presentation. Yeah, good.
Okay, so now when we talk about something, it's always to have a methodology. If there is a methodology and you follow the methodology, 99% chances that you will succeed, right? If you want to cook, if your mother tells you how to make dal, how to make sambar, have a methodology, follow that methodology, you will be successful. You don't try to follow the methodology, you might not be successful. AICTE has got a methodology to teach. Your college has got a methodology to teach. So everybody has a methodology. The methodology for machine learning, one of the methodologies, okay? This is not the methodology. There are few methodologies as well, but one of the very commonly used industry methodology for machine learning and deep learning is called as CRISP-DM. This is a very, very good buzzword. CRISP-DM is nothing but cross-industry standard process for data mining. Cross-industry standard process for data mining. So CRISP-DM was created in 1996. A buzzword in 1990, data mining. It is the predecessor of data science. So prior to 1990, everybody was referring to data mining. What is mining? Mining is about digging for information, digging for gold, digging for coal. So when you dig your data, you get a lot of insights. So that's what data mining is. So data science is sitting on top of data mining. When it comes to the CRISP-DM methodology, these are the 6 steps. How many steps we have? 6 steps. The number 6, okay, belongs to the planet Venus. Shukra. Understand the business problems, data collection, data cleansing, preparation of EDA, feature engineering, data mining or machine learning or deep learning, evaluate your model, deploy your model. So these are the 6 steps that has to go through when you want to put your machine learning into play. Let's take a deep dive one at a time and try to understand what I'm talking about. I'm going to be asking some questions, so please be alert and put all your attention right into this. Do not miss the next 10 minutes. This is the top class, most important part of the training. So business understanding is we try to formulate the business problem, understand the data, prepare the data. Based on the data, there are multiple models I showed you. Come up with the right algorithm to use, evaluate your algorithm, feel good, deploy it. So how do we do this, sir? Get ready, go. Business understanding. Usually we have a business person who formulates a business understanding, right? When you want to do a business, the moment somebody comes and tells you a problem as a data scientist or an AI specialist or a deep learning specialist, these are the 2 things that you have to draw up. Record your business objective, record your business constraint. You have to write them in 2 to 3 words. It should use the terms minimize and maximize. Excuse me. Example, if a job is boring, hazardous, tension-ridden, lacking in opportunity for advancement, very few persons may be available for such jobs. This is the business problem that they have given you. How would you declare a business objective and a business constraint? Example, the business objective would be, I want to maximize the incentives, right? That's my business objective. Constraint is, I have to minimize the risk and tension. I want you to understand the connectivity between this. The objective cannot be achieved because of the constraint. The problem, see what is it saying? The job itself is hazardous and tension. I want more people to come and work in my job. I have to minimize the risk and tension. So it becomes difficult. So let me give you a very simple example. Credit card company walks up to you. Consider all of you are the chief data scientists of an organization. They walk up to you and they say, team, we have a problem. We have a lot of fraud transactions happening. Every time somebody swipes, so if 10 transactions happens, close to about 7 to 8 transactions are reported to as fraud, and it is creating a lot of headache. Is the business problem that they have given you. Can you formulate the business objective and the constraint? What is the business objective first? The problem that has been given to you is there are a lot of transactions happening. We are happy, but 80% of the transactions are fraud. So what is the business objective? What is the business constraint? Go ahead, shoot your answers. Don't worry, no answer is a wrong answer. Like doctor said in the morning, be bold, come out, speak. Don't worry whether the other person will think you didn't know the answer. You know, if you answered even the wrong answer, means that you are putting some effort.
They are giving like good answers. Krishna Kanta.
What is it? What is it? Let me just try to.
Minimize the fraud.
Validation is required. Avoid fraudulent active business. Minimize fraud. Constraint. Not easy to predict fraud before. Very good. Okay. Good. Give me like business objective and business constraint. You please write that. You don't have to, you know, BOBC. You can write like.
Yeah, Manaka says to increase the revenue.
What is that, Manaka? To increase revenue for what? Reduce fraud. Excellent. You guys are good. So, the easy way out is I can go back. Yes. Very good. Very good. Nice. See, they are thinking, doctor. I can go back and tell the company that, hey, you know what? Create password, send an email, do multiple things. No. You know, reduce your business. I can't say that. See, the business objective is I want to increase the credit card sales. Business constraint is I have to reduce the frauds. So see, it is, you know, it is right opposite each other. It is like, you know, 90 degrees, right angle triangle. It's in a right angle, perpendicular. So this and this are not close to each other. So very good. You guys understood it very good, because we're going to give you homework on that. That's why. Did you complete yesterday's homework, all of you? Doctor, did you check with them? Did they complete their homeworks? Check with them. Okay, next is data understanding. Doctor is going to cover this in detail in the afternoon session, but I will run through this pretty quickly. There are different data types that you need to know. Continuous data and discrete data. Continuous data is nothing but that can be represented in decimal format. Temperature can be 10.2 degrees. Weight can be 50.3 kilos. Height can be 5.1. Discrete data are data that cannot be represented in a decimal format. Can you say I have 1.5 mobile phones? Can you tell I have 2.5 cars? You cannot say that. So anything that cannot be represented as decimals are called as discrete data. Continuous data. These two words are very, very important. You will hear this throughout artificial intelligence. These data types, please be very thorough on this, because they'll be using this left, right, and center. The algorithms are based on the data types. Some algorithms you cannot use if it is continuous data type. Some algorithms you can use only if it is discrete data type. So please be very clear. That's why doctor is going to spend good amount of time on that. Within discrete data, within continuous data, you have interval data and ratio data. Interval data is nothing but, look at this keyword, it is subjective. What is subjective? If it is temperature, 10 degrees for the madam who was there, I don't know whether she's here today, from Jammu and Kashmir, you know, is okay. It's not cold. You and me, we'll be shivering. Oh, yo, people from Delhi, not a problem. Chennai, forget about it. 10 degrees, you have to give me some 10 blankets. It's subjective. I will say it's very cold. The person from Jammu and Kashmir and the person from Delhi might say, it's okay, 15 degrees, okay, we can manage. So that is interval data. Anything that is subjective. Anything that is objective is continuous data. What is objective? It means the same to you. 50 kilo weight is 50 kilo weight for you, 50 kilos weight for me as well, right? If I'm saying my phone is 10,000 rupees, it's 10,000 rupees for you as well or for me as well. So it is the most preferred data. Within discrete data, are you guys able to follow those subjective, objective, interval ratio? Just confirm. I'll keep moving. Categorical has got binary, multiple. Discrete data is also called as categorical data. Within categorical data, we can have binary. It's 1 or 2. People are responding, doctor?
Yes, there are many yes.
Okay, they understand. Okay, perfect. So this will be an easy platform for you, doctor. You can take them more into detail. So categorical data is of two types. One is nominal, ordinal. Nominal is nothing but just names which doesn't make any sense. Jersey number. Dhoni wears what number does Dhoni wear on his shirt? The number. Cricket fans.
7. They gave a lot of 7.
7. So the number 7 doesn't make a lot of meaning. Color green, red doesn't make a lot of meaning. So those are called as nominal data.
There is Mahendra Kumar Sahu. Mahendra Kumar Sahu. He gave the answer also. Thanks. Kudos.
Very good, very good. So then we have ordinal data. Ordinal, the word itself, computer science, common sense. Ordinal, order. So anything that is categorical and ordinal is something like military ranks. Second lieutenant, first lieutenant, captain, major, lieutenant colonel, colonel. When you buy clothing size, small, medium, large, first rank, second rank, third rank. So these are all discrete, categorical, ordinal. See, all this will be used in algorithm, guys. Please make note. Please make absolute attention. Okay. So this is more example on that. So when doctor covers it, you can enjoy. He's very good at it. He's a data man. Same thing here. So this also is going to cover, but I'm going to touch upon when it comes to data, there is qualitative data, quantitative data. Qualitative data is about quality of the data. Quantitative data is the quantity of the data. Then we have structured, unstructured data. How many of you are aware of these two data types? Structured and unstructured data. Anybody knows? Can somebody give me an example of structured data? Somebody give me an example of unstructured data?
They say some idea.
Can somebody tell me, give me an example of unstructured data?
Which they use day to day. Oh, Krishnakanth says structured means all tables, Excel and all.
Okay.
And then it also says that. Saranya says image, video, audio will be kind of unstructured.
Very good. See, yesterday I told you, I gave you a clue for my questions and answers. What did I tell you yesterday about when I ask a question? What did I say? I gave you a clue for you to give me answers. What was that? Whenever I ask a question,
Common sense. They say
common sense, no. So you guys didn't pay attention. Whenever I ask a question, I said the answer will be right in front of you. Did I say that? Did I say that or no? I didn't say that? Yes or no?
Lot of yes.
So the answer is right in front of you. Are you able to see my PPT? It says there, examples, MySQL, Microsoft SQL, Oracle DB, unstructured data that cannot be pasted in tabular format, video, images, audio. That's all. You know it. Beautiful. That's all. So anything unstructured. So this is where doctor is going to be talking about big data. MongoDB is going to be an unstructured, no SQL database. We're going to be talking about it. These are the big data versus non-big data. Volume, data generation at rapid. There's a 4 V's, 5 V's. There are so many V's coming up now. I'll only talk about the 4 V's. Doctor will speak more about the other V's because he's a VVIP. Volume, huge volume of data. Velocity stands for data generated at a rapid speed. Variety, videos, images, the variety of data is different. Veracity, uncertainty. All of a sudden, there's a whole bunch of data coming in. Sometimes it won't come. So I want to ask you a small question on this big data. What do you think, as per your knowledge and understanding, what is big data? Don't give me PhD answers. Give me LKG first standard answers. Simple layman terms. To you, that comes to your mind. Big data, the moment you hear the word big data, how would you define it? If your kid comes and asks you, or if you don't have a kid, somebody comes and asks you, what is big data? Yes.
They're giving good answer. Our mind, huge amount of data, continuous stream of data, large data to handle, large volume of data, more data.
Excellent. Super. Let me ask
Raw
you
data.
Let me ask the next question. Okay. Let's assume You have 500 GB of hard drive in your computer. If I give you 250 MB file, is it big data for you or not? Your computer is 500 MB. I'm giving you 250 MB file. Do you think that can be classified as big data for you?
They say no, no, no.
Excellent. Excellent. If I give you 1 terabyte file, would that be considered as big data for you or not?
They say yes.
That's it. Beautiful. Professors, doctors, engineers, you guys are the best. That's it. So there is no specific definition for big data, okay? Don't think 1000 terabytes of data is only big data. Some 10 petabytes, some zettabytes of data is only big data. No. Big data can be applicable to you also. If you can't store it and you buy a 2 terabyte hard drive and store the files, it's big data for you. That's all. Just remember that. So it is a relative. Big data is a relative term. If anybody asks you, teach your students. This is a very important interview question. I ask always. 99% of the people don't answer this. They will say all kinds of different answers. Okay. Then there are two types of important thing. There are two types of data sources, because your machine learning is based on the data. No data, no machine learning. So primary data source, secondary data source.
Ranga, somebody say, excuse me to interfere. Somebody says, can you repeat, sir? Sweta Ranjani is asking you.
Which one you want, madam? Which one should I repeat, madam?
Yeah, what?
I think about big data. You gave some example now. Maybe she is asking.
Can you please be specific, Sweta madam, on what you want? Which part you want to be explained?
Big data example. Example of big data.
Example of big data. See, these are any data that cannot be accommodated by you. Let's say, for example, one flight journey creates 847 terabytes of data. One flight journey going from, let's say, from Delhi to Frankfurt, right? That is big data. No, how many? Let's say airlines, Lufthansa has got 100 aircrafts. If one trip is going to create 847 terabytes of data, you think Lufthansa can buy enough servers and store all those terabytes of data? Do you think, madam?
No.
No, sir. No, sir.
No. So that is what is big data. So anything that you cannot handle becomes big data. That's all. A simple explanation. You will understand a lot when doctor talks about it. Did I answer your question? What is big data?
Yeah,
Anything,
kind of, we got it, yeah. Yes.
yeah, anything an organization or individual cannot handle is big data.
Sorry to interfere. One person, Saranya, has told that, can data beyond my storage capacity is a big data? That's the question.
Yes, yes, madam, exactly. Anything that is beyond your storage capacity is big data. That's why I gave you an example. If I come back and give you 10 terabytes of data, that is big data that you need. Let's say you need that 10 terabytes of data as an organization, right? Amazon, imagine Amazon, how many terabytes of data they create every day. They can't just store it, and they can't also read it. That's where the volume, huge volume, generation speed, and also wide variety of data which cannot be handled by structured SQLs.
Yeah.
All this fall under big data.
Yeah, Ranka, with your permission, I'll say one simple example.
Yes, go ahead.
The YouTube data, like say YouTube and then tweets and Facebook and Instagram. See, like, do you think that Facebook can maintain with one server? See, like say if I have a local system, if Facebook maintains one server, so they have to distribute the data across so many things, like say tweets. When Modi tweets or Rajinikanth tweets or somebody, Amitabh Bachchan tweets,
Exactly.
much of tweets are going,
Sure.
they can maintain in one single server. Basically, data will be distributed in multiple places, and instead of storing data in one place, it gets replicated in multiple places depending on the accessibility. The data will be retrieved. Google, a lot of Google data, search data, all will be in the big data. We will see little extensive example, and probably God wishes permits, I will show you how to look at the Hadoop file system. Some examples I'll tell you, like how you can connect your data to push your data. Right now, what you're doing, basically, when you can't save the file, you upload it. Madam shared that link yesterday, Google Drive.
Yeah, good example, doctor, to give them. Big data example is all of you got a link to watch the videos, right? Yesterday's class. All of you, madam sent the link for yesterday's session, right? So is madam storing all the data in SASTRA University, madam? Are you storing it there in your server?
It is being stored in Drive, Google Drive.
Yes, that's big data. Madam cannot handle that quantity of data in their servers. So that is big data for you. Yes, doctor. Can I proceed?
Yeah, go ahead.
Okay. So good questions. You will understand slowly and steadily. By the end of 5 days, all of you will have very good hold on all these different buzzwords, and you can develop on them. So then the data collected at source, primary data sources are data collected at source and data collected beforehand. So basically, this is very good from the machine learning point of perspective as a primary data source, but it is most expensive. You can do a survey, you can design experiments, simulate, social media extraction, IoT sensors. These are all data collected at source. Okay. Sometimes IoT sensors can also be considered as a secondary data source because they could take information and store it in the history. Secondary data source is something that has already been collected and stored, like RDBMS, CRM, SEM, SQL databases. Any data, there are also sets of data that is available called as syndicate data. For example, you can go to AirTel and AirTel will sell all our phone numbers to you. That is syndicate data. Or there can be a medical syndicate where you can go and ask for all the cancer patients' data. They'll give you, right? So those are all also available. That is easily available, but it might not have all the variables of interest that you want to run your algorithms on. Okay. Then data cleansing, doctor spoke about this outlier analysis, and one of our friends asked about data munging, data wrangling. It's all the same, sir. Data cleansing, data preparation, data munging, data wrangling, data organizing. It all means the same. Tomato, all same. It's all takali. So it all remains the same. So outlier analysis and treatment. This is a very, very useful technique called as 3R technique: rectify, retain, and remove. You can check if there is an outlier. You can see whether you can rectify it, or if you cannot rectify it, you can remove it, or you can just leave it as a NaN value. Okay, this masking and swamping, or false negative and false positive. This is, there is an outlier, but you fail to detect. Swamping is you are detecting outliers, which are, doctor will cover false negative and false positive when he's talking about the confusion matrix. So these are some of the imputation techniques I was referring to yesterday. Some of you already answered that. You can do a mean imputation, medium imputation, mode imputation, K-NN imputation. These are all just informational purposes only. Then we have 4 different business moment analysis. First moment business decision, you guys saw that yesterday, mean, median, mode. Second moment business decision, also doctor showed you, variance, standard deviation, range. Third moment business decision is skewness. You check whether the data is left skewed, right skewed, or normally distributed. Then we also have the fourth moment business decision, which is called as kurtosis, which is the, if it is equal, kurtosis equal to 3 means normal distribution, negative kurtosis, and positive kurtosis. So these are all deep diving and advanced areas when we can cover later if all the management and the AICTE, everybody permits. We can go more into detail on statistics. That's where we are talking about statistics. Makes a lot of sense. So this is supervised machine learning, consists of predictive modeling, regression model, simple linear regression. See here, I told you this continuous, multiple, these are all coming. So Y means output, X means input when it comes to machine learning. So if your output is continuous and your input is single, you will use simple linear regression. Your output is continuous, and if your input is multiple, you will use multilinear regression. Then we will also look at some of these transformation techniques for logarithmic regression, exponential regression, polynomial. See here, I told you, right? Simple logistic regression is used when your output is discrete in two categories and single. Discrete, I said, full, yes or no. So you are saying whether the patient has got COVID or not, whether the patient has got cancer or not. So obviously there's going to be yes or no. So that is two categories. Yes or no is two categories. You can also have multiple categories. See here, Y is greater than two categories. We are using multinomial regression. When can you have more than two categories? Is the output can be, if I'm going to predict if Dr. Venkat will take, if he has to go to the airport, will he take the train? Will he take the bus? Will he take his car? Or will he take Ola cab? So there are four categories, right? So that way we'll use multinomial regression, okay? Then classification models. So that's why I said discrete, categories, all will be used. So you should know the data types. So the evening session as well as the morning session, which I covered, is going to be very helpful. The classification model has shallow learning algorithms, k-nearest nearest neighbor. We're going to cover all this. So you have all the data and you built your model. So how do I go about checking whether my model is good, bad, ugly? So far, so good. All of you are with me, rather than me just.
Yeah, they are with you.
Okay. Following, understanding, are all experts now? You guys can call yourselves data scientists. Ready? Okay. All right. Machine learning 101, right? So when you have done here, one thing, if you notice, I spoke almost 30 minutes on what? The three steps of the, even though there are 6 steps, of the 5 steps, I spoke 30 minutes on the first 3 steps. So what does it tell you here? Please remember, this is where a lot of people make the mistake. When it comes to machine learning and deep learning, of the 100% of the time, what happens is 60% goes to understanding the business objective, coming up with the constraints, data preparation, data cleansing, collecting your data. 60% of the time has to be spent there for you to have a fantastic model. To build an algorithm and build a machine learning model, it is only 20% of the time, ladies and gentlemen. And then another 20% goes to the deployment. So in today's, pretty much out there in the industry, the training industry, people spend a lot of time trying to learn the algorithms. You are making a mistake. Tell your students, if they are trying to come in and tell you, madam, I know this algorithm, I know that algorithm. Yeah. How much you know about understanding the business requirements? How much you know about data cleansing? How would you do the outlier analysis? How would you know which features to take, which features to drop? If you don't know that, you are not a data scientist. You are not an AI expert. Please understand that. Take that 100% into yourself. Propagate that. More they do these first 3 steps, that makes them a fantastic AI expert. Okay, so that is key. 60% goes there. Okay, so that is an important thing that I wanted to pass it on. Once you take that model, what do? I will build the model and I will train the model. Once I train the model, I will do, see, let's say I have 100 observations. What is an observation? Ladies and gentlemen, in machine learning and artificial intelligence, what is an observation? I have 100 observations and 4 features. What am I talking here? What did we tell you yesterday? What did I tell you yesterday when doctor was showing you the programs? That the flower petal thing. What is observation? What is feature?
Rows and columns they're giving.
Beautiful, beautiful.
So,
Observations are rows, features are columns. Remember that, but they will never say that here. Okay, rows and columns. Nice. So let's say I have. So when I say 100 observations, you will immediately your mind should say, okay, he's talking about 100 rows. I will take that 100 rows and split that into 60 for training, 20 for validation, and 20 for testing. Why? I will tell you. So when you are building a model, you will have to validate the model, and then the reason for splitting this data into 60, 20, 20 is when I'm training this model, I'm giving it only a certain set of data that it can train on. And then I will come back, I'll show you today, if there are some errors, I'll come back and I will change the hyperparameters. These are something called as tuning parameters. So you have a bike and you're saying that I'm just running and it's giving me only 40 kilometers per liter. So you go back to the mechanic and he will adjust some parameters. He will tune something and it will probably start giving you better results. It will start giving you 45 kilometers per hour. He will say, sir, drive it like this. It will give you more, right? Then you put it into production and then it starts working. So with the right setup, so you will say, okay, this is what they do. When the example that I gave applies that for all the car manufacturers. They will build a car, they will train the car, they will validate with the parameters. So they will know if I set this at this RPM, it is giving me the best. So they will apply that in production. So that is testing. So training, you will build a model, train your machine on that, and then you will validate with the 20% data, and then you will test it. So what you're doing here is you are training something, you're validating, and that test data you're not exposing your testing system. So when it goes into production, it will work properly. Once you do the training and testing, you will have to check for errors. That is one of the key points of all the artificial intelligence algorithms. Testing error or training error or testing accuracy or training accuracy. So if I say 96% accuracy, all of you are good at math. If I'm going to tell you my model is giving me 96% accuracy, what is the error rate? Answers, please. If I'm telling you my model is giving me 96% accuracy, what is the error rate of my model?
All are responding as 4%.
Excellent. So 100%, 96 accuracy, 4% is the error rate. So we need to find how is my error doing. So these three are the buzzwords of artificial intelligence algorithms: right fit model, overfitting or variance model, underfitting or bias model. Okay, what right fit means is I am training my model, the error is low. I am testing the model with the same machine learning, it is low or close, then it is a right fit model. Always remember, we want to have a right fit model. If the testing and the training error are low, when you put this model into production, the predictions coming out of that model will be very good. What is overfitting? The training error is low, testing error is high. When does this happen? When you train your data set on the same type of data. So I'll give you a very good example in the next slide. It's like somebody going to a tuition for mathematics. He is solving the same type of problem over and over and over and over again. So he's solving, let's say, the last 5 years question paper. Again and again and again, he did some 10 times, 100 times. The teacher is giving questions from the same question paper. He is picking some random questions and giving. He will get 100 marks because he already trained on that. Now, I expose him in production, in the live test, to a same concept, but different twisted. differently twisted, he is confused, he won't perform well, he will fail in the test. So that is called an overfitting. You don't want to have an overfitting. You will have to follow regularization techniques. We will explain how. Now comes training error and testing error, both are high. Here, this is a student who didn't study well while training. He didn't attend. Then obviously he will not perform well. So if you didn't attend properly here, you will not be able to answer your quizzes properly. So this is called as underfitting. We will do feature engineering. So just remember, right fit is you should train good enough where your error is low. See, error is what? Actual predicted minus actual. So if I'm saying I'm predicting an house price in Hyderabad based on the previous data, I have been given, if this is in this area, this will be the price of the house. Let's say 25 lakhs. I am getting a similar machine learning prediction. I have employed my model, given it to my customer. So people are coming and giving, so it's a house in this area. Okay, let's say Kukatpalli. Okay, or Panchaguta. It's in Panchaguta circle. It's got 2 grounds, so and so. So I'm feeding this, and it's going to say 24 lakhs 50,000. My actual prediction is 25 lakhs. So I'm not too far away from that, right, guys? 25 lakhs was the actual data that is sitting there, and I predicted 24.5 lakhs. That is a right fit model. Overfitting model will completely go out of bound. It will say something like 50 lakhs, but it is actually 25 lakhs. It's a huge difference, very high error. Underfitting is, it will say 20 lakhs or 15 lakhs. So it will undercode. So these are the areas that you need to avoid. So this is a similar example. So these are some of the...
And there is one question.
Yes.
For your, that is just now you completed one slide, isn't it?
Yes.
Training, validation and testing. Question from Ms. Menaka. So it is always we have to split up into 60 plus 20, 60s to 20s.
Yeah, good question, madam. We call this in artificial intelligence, deep learning, machine learning, something called as empirical. Empirical means it depends on your experience. This is basically, there is no prescription. Ladies and gentlemen, there is no prescription for a lot of the machine learning, deep learning algorithms. You can split it otherwise, but generally for the industry experts say splitting it in 80-20, 70-30, 60-20-20 works better. That will answer your question. You can play around with it. Machine learning, deep learning is all about playing around with parameters. You can try to do a 70-15-15. If it works for you, good. Or you can do 50-25-25. It works for you, good. You can try different options, madam. There is no set rule, but this is the recommended based on their experience.
Sure. One thing to add with that, see, when we do a splitting, we also look at how much information we are going to gain. And, based on that, the weights can be adjusted, depending on the context. It's basically depending. Suppose even Ranga said this morning, when he's talking about temperature, right? So you have to adjust the weights, and the distribution would be based on how much information gain I'm going to get. Is it going to support, is it going to be underfit or overfit, and what would be the right distribution, right weight? That is based on case to case.
Yes.
So Ms. Deepika Sharma says, which means that training requires most of it.
Yes.
It is okay.
Yeah. But give more to training, because you need to train more. Because you want to take a class, you cannot just come in and do it. You have to train yourself. More training, the better. Yes, correct. So this is a pictorial representation of original set, training set, test set. See, there are 2 ways people do it. You can just do a train set, test set split, 70-30, 80-20, or we recommend this training set, validation set, and a test set, where you can do the training, tuning, and evaluation for the machine learning, and you give it to the predictive model. This is how a graph will look. If you have done an underfit, optimal fit, overfit. So test error, see I said split randomly to avoid bias. And also one more thing is you have to split the data randomly. Don't go split the first 60 rows to training, second 20 rows to validation, and second 20 rows to test. You have to do a random split. You'd have to go and take randomly 60% of the data, 20% of the data. Then you will get a good result to avoid this fitting problems. This is what I was telling you in a very pictorial way. So you will be underfit because you scored very high in the class test because you practiced a lot, but a different question came. You only got 47%. You are on an underfit or a biased learner. Here, this guy, overfit guy, is what? He's a memorizer. He will just keep doing the same problem over and over, rotting. He memorizes the lessons. If you give him the same question, he will get good marks. If you twist the question, you would have seen a lot of students like this being professors. So you would have done a little bit of twist, gone. He got 98 in the class test, actual test 69%, university exam. You can apply this, guys, to your students and classify them as best fit, underfit, overfit. Start doing that. So you're also learning AI, and you're also classifying your students. Nobody will understand. You professors can talk to each other. Oh, that is an underfit. This is an overfit student. This is a best fit student. Okay. So we do that in business. I do that in business. I'll say this is an underfit customer, overfit customer. Conceptual learning, you learn the concepts. You get 92 in class test. You get 89 in the board exams. Okay. Okay, good. So I just want this. It was a little out of place. So I want to show that. Then comes to the business understanding problem. Is exactly we explained. Business understanding, data understanding, preparation, modeling, evaluation, and deployment. So this we explained. Quantitative is discrete, binary nominal. We already discussed this. So this is how the machine learning algorithms complete flow. Raw data, pre-process it, clean the data, extract the features, model it, evaluate your results, then choose whether you want to do supervised or unsupervised learning, and then you put that into discriminative features and you label them. Okay, so these are the different ways of going about machine learning algorithms. So this is a cheat sheet on machine learning algorithms. I just had this so that you can refer to it when you get this. How do you use what you will use for dimension reduction, supervised learning, classification algorithms, and unsupervised learning. These are some of the deep learning algorithms. We'll be looking at some of these ANN, KNN, logistics regression, decision tree, K-means. We'll be looking at CNN, RNN, LSTM as well. So again, how would you go about data collection and cleansing in a pictorial way? Import the data, merge it, rebuild, standardize, normalize, deduplicate, and use it. So what if you have outliers? How will you handle the missing data, duplicated data, non-normal distribution, and so on. So this is for the imbalanced data set. Let's say, for example, you're having a data set that has been given to you that is not balanced. So I got a data set with 50% male and 50% female. It is a balanced data set. What if we get an imbalanced data set where 90% are negatives and 10% data? So what you have to do is you will use something called as sampling method. These are all a little bit advanced topics. This is what actually is being done by all the, let's say, when they want to when they find a medicine for COVID, they're not going to be applying this on everybody. They have to get the right set of balanced set of data. They will use sampling methods. Okay, so some of the sampling methods they will use to create a balanced data. Feature engineering is nothing but taking multiple features and trying to compress them into a single feature. A good example is we get a problem that has been told to us that, hey, I am getting a lot of fraud transactions. So the customer gives you time of current transaction, place of current transaction, time of previous transaction, place of previous transaction. So I'm going to tell you, as a data scientist, I don't want so many columns. There are 4 columns. I want you to do feature engineering, because this can give you overfit problems. Okay, there is something called as dimensionality curse. Doctor will be covering that in the afternoon. Dimensionality curse is having too many dimensions or too many features. So you know what a feature is. Too many features, too many columns to handle is a problem for machines. So you'll need to compress this, which is called as feature engineering. You're all engineers. Tell me how this is being done. They have gone from 4 to 1 feature. Tell me how this has been done. Just look at the slide and give me the answer. What have they done?
They're still thinking.
I gave you 4 inputs. They made it 2 inputs, and then they finally came into 1 feature. They made it into a 1 feature. This is called as feature engineering.
They're still thinking.
So the credit card company tells me the time of the previous transaction and the time of the current transaction. The credit card company tells me the place of the previous transaction and the place of the current transaction. I want to have only 1 feature which will give me an answer on all these 4 inputs. Easy, simple. Current minus previous time will give me the time lag when this happened. The first transaction happened at 8 o'clock, the second transaction is happening at 10 o'clock. So it's happening at a 2-hour time difference. The distance, where was the previous transaction? It happened in Hyderabad, and the second transaction is happening in Chennai. Whoa, there is a distance problem. So this guy is, straight away you can say this guy is using it online, or he's sharing the credit card, because within 2 hours he cannot travel from Hyderabad to Chennai, or maybe let's say 30 minutes. Maybe you can argue that you can take a flight. So let's say 15 minutes. So within 15 minutes it's impossible. He has to take a supersonic jet to come here. So obviously all of us know what is velocity, distance by time. So I can have 1 feature which can tell me input on all the 4. So this is what is called as feature engineering. Okay, all of you are with me?
They're all with you. Ranga, it's almost 10:40.
Yeah, I know, that's it. It's over. So this is the, I'll just show them the practical session. So we have parametric machine learning and non-parametric. Parametric is where you can have the input. Non-parametric is where you don't have the input done. This is the error that we were talking about. Okay, accuracy in error. So predicted minus actual. Okay, so this is the root mean squared error. Doctor, will you be able to cover this in the afternoon, root mean squared error, or I will come in and explain them about this?
I think
quickly explain this. Root mean square error is very important. I'll explain this really quick, and we can run the code. See, this is actual minus predicted. See, actual is 100. The predicted value is 101. So the error is 1. Then consider this 4. Consider this 4 observations. 100, 101. So this is giving me 1. 200 minus 199 is giving me minus 1. 300 minus 301 is giving me 1. 400 minus 399 is giving me 1. If I just do a math on this, what am I going to get? I'm going to get 0. So you're telling me there is no errors? Wrong. There are errors. So what they said is, the statisticians, hey, this is not the right way to do. Let's take a mean absolute deviation. So we know absolute will make it 4. Okay, so they were not still satisfied with that mean absolute deviation alone. So they said, can we make it even better? So they said, rather than taking a mean absolute, what we can do is we can square it. I can square the errors. If I square the errors, what happens? 1 square minus 1 square plus 1 square will make it 4. So let's say dollars, it's in dollars. I'm having $4. What happens when you do a square? It also gets $4 squared. What is my error? If somebody comes and tells you $4 squared is the error, sir, will you understand? You know 4, but dollar square, what is that? Doesn't make sense. Centimeter, creates a confusion. So they said statistician is smart. Okay, fine. If I want to take the square of, what do I do? From an expression, $4 squared, I have to take it out. What do I do? Answers. Answer is right in front of you. You take a root. That's it. You take a square root of it, you will get $4 to $2. So this is called as, this is a very, very useful calculation that's used in machine learning. RMSE, root mean squared error. There is also something called as mean percentage error, where this can be represented as a percentage. Okay, so these are the different linear regressions, polynomial, support vector. This is what we're going to be looking at. All of you know what is this formula? What is this formula? Anybody knows what this formula is? What is the equation for a line? Line equation. Are there answers? Are the people answering?
Y is equal to mx plus c is the line equation. And what you have given is a b1, you can take it as a slope, b0 is the constant, x and y forms the line.
Beautiful. Yes, madam. So that's exactly what we are going to apply here. So y is your predicted value. Beta naught is the slope. Okay, it is called as a coefficient in machine learning, and beta 1, x1. So these are all the variables that can come out. So this is a constant. It will always be this slope will be constant, and then this b1 will also be given by the machine learning algorithm. So this can keep changing. So if this is done using ordinary least square method. So we're going to find out. See, this can be error, multiple errors. So we're going to be find the best error. This is called as the ordinary least square method. So this use case methodology is, we'll probably run it now, or even we can run it when we come back from the break, or even we can do it in the evening session. I'm going to show you a live example. I'll quickly explain this use case. What has been found out is there is something called as an adipose tissue, which is in your abdominal region. Depending on the adipose tissue, the doctors are able to predict, right, whether you will get heart attack or not. That heart attack of this AT is measured based on a computer tomography. You have to go for a CT scan to find out your adipose tissue. Going to do a CT scan is expensive. It's a lot of people don't have access to technology. You have to go through this irradiation. It's expensive. So people thought, what if, based on all this data, I can just go get the data from a CT scan company and say, okay, what was the waist circumference of a person who had this adipose tissue calculation? So the mapping will be given. So if you have waist circumference of 90 centimeters, this is adipose tissue you have. They will give a historical data. I can build a machine learning model based on the waist circumference. So when you come here, you see this, I will predict the salary if you give me the experience. So here, similarly, I will predict your adipose tissue if you give me the waist circumference. This is what we're going to see as a hands-on for our simple linear regression. So being 10:46 now, so what should we do, madam? Should I run through the hands-on or give them the break and do the hands-on when we come back?
Sir, let us have a break.
Okay, madam. So we'll have a
Because
quick
it's
break, probably
already
come back by
10:45.
10:55 we can come back.
Yeah,
Sure,
we'll
sir,
finish
sure.
at 11 o'clock. Yeah.
15 minutes, 11 o'clock.
Okay.
Can we have
All right.
10:45?
Okay. Hopefully it was informational and you were able to follow. I think I
Yes,
did
sir.
justice to the session. So
So good, sir. We are very happy.
thank you.
for the nice session, sir.
Thank you. We'll run a hands-on when we come back. Or
Sure,
in the,
sir. By 11 o'clock, sir.
yeah.
We'll
Thank you.
meet again 11 o'clock, sharply at 11.
Thank you.
Thank you, everyone. See you after a break. Thanks,
Thank
Ranga.
you, sir.
வீட்டுக்கு வாழ்ந்தாலே கஷ்டம். இங்க வந்து அது கும்போணத்துக்கு வந்தீங்கன்னா நீங்க எடுத்து ஒரு பெரிய அவளா சொன்னா ஞாயிற்றுக்கிழமை போயிருந்தேன். நான் வர ஊர்ல 2 நாள் வாழ்க்கேன். பாட்டிக்குள்ள வந்து 2 நாள் சண்டே போயிருக்கேன். சண்டே பிளைட் புக் பண்ணி சண்டே போவோம். ஃப்ரீ ஆயிடுச்சா பிளைட்? அந்த பிளைட்லாம்
ஃப்ளைட்லாம் வரேன். இன்டர்நேஷனல் ஃப்ளைட் செட் பிக் பண்றாங்க.
இன்டர்நேஷனல் ஃப்ளைட்ஸ் ரெஸ்ட்ரிக்ஷன்ஸ் நிறைய இருக்கு. காஸ்ட் டபுள். ஆமா, காஸ்ட் டபுள் ஆகுது.
குவாரண்டைன் கரெக்டா இருக்கு. அங்க போய் குவாரண்டைன் எந்த கண்ட்ரி போனாலுமே அங்க ஒரு 5 days குவாரண்டைன் பண்றாங்க.
இங்க 10 days
அங்க இருந்து வந்தாலுமே நம்ம சர்டிபிகேட் டெஸ்டிங்லாம் இருக்கு. அதெல்லாம் செஞ்சுட்டு தான் வராங்க. வெங்கட் பையனே இப்போ வந்து ஸ்டேட்ஸ்ல இருந்து யூஜி முடிச்சுட்டு வந்தான். வீட்டை பார்த்தா அவன் ஸ்டேட்ஸ்ல தான் பண்ணான். யூனிவர்சிட்டியில பண்ணான். அவன் முடிச்சுட்டு இப்போ தான் வந்தான். பிரான்ஸ்ல ஏதோ யூனிவர்சிட்டியில வந்து அவனுக்கு அட்மிஷன் கிடைச்சிருக்கான். ஸோ அவன் பிரான்ஸ் பயோ இன்ஜினியரிங் பயோடெக்னாலஜி.
நீங்க கிரீன்டியா?
மத்தியானம் கிரீன் கிளைமேட் பண்ணுவாங்க. எனக்கு கிளாஸ்
Ma'am, Sudha ma'am or Alirani ma'am, I think record is on. I think we should pause.
இருக்கு. எனக்கு எல்லாருமே பின்னாடி இருக்காங்க.
Sudha ma'am. Sudha ma'am. Sudha ma'am. Okay, cell.